Hello everyone, my name is Putra with my student name is 24055310225. We're going to discuss about the simple pendulum experiment that I did, and then we're going to just go right into it. Background. This experiment, the simple pendulum experiment, is typically conducted to determine the acceleration due to gravity and study the dependence of the time period on various factors such as length and amplitude. Now, the first one who studied the properties extensively of the simple pendulum is Galileo. A simple pendulum consists of a small bob suspended from a fixed point by a light or a string that swings freely under gravity that when displaced from its equilibrium position and released, the pendulum oscillates due to the restoring force of gravity acting on the bob. Now, system pendulum equation. This is the one that we're going to use at our summary and how do we find the gravitational force in every single data collection that we're going to get. Now, the first one is F equals minus M times G times theta. F equals force, that is in Newton or N. Theta is angle, that is in degrees. M is mass, that is in kilograms. Now, that's how we search force in the simple pendulum. And then we are going to search for period. Period, we could search it with period equals 2 pi root of a L per G. Now, T is the period, as I said before, and G is the gravitational force, or that is in M per S, and L is the length of the string that we use. Now, that is in meter. Now, the third one is how we search for our gravitational force. G equals 4 pi squared times L per T squared. Now, that is how we search for our gravitational force. This is the tools that is needed for simple pendulum experiment. We needed mass, string, protractor, stopwatch, ruler, and lap stand. And this is going to be, and I'm going to tell you about the steps that we are going to do for this experiment. First, we set up experiments by tidying up and set up the tools that we need for the experiment. Now, second is we measure the length of the string, which in example is 20 centimeters. And then we're going to put the pendulum at a 10-degree angle. We swing the pendulum for 10 times periodically and take a note of it with a stopwatch, that how long does it take for the pendulum to complete its movement. And then we repeat step 3 and 4 3 times and calculate the average of how much the period and the time that it takes to complete their movement. And then we repeat step 2 to 5 times with a different length of the string, but with the same angle, that is in 10 degrees angle. Now, this is our first data collection. With the length of 20 centimeter, we get the highest width is the second one, with a time of 9.46 seconds with a period of 0.946, with the period squared is 0.896, with the average period is 0.937, and the average t-squared is 0.879. The second data collection, we get the highest of 10.10 seconds with a length of 26 centimeters. This is the string that we're talking about with a various string. Now, we get a period of 1.010, and the period squared, or the t squared, is 1.021. Now, the average of the period in here is 1.008, and the average of the t squared is 1.018. This is going to be the third data collection with a length of 35 centimeters. The highest is 10.88 seconds with the period of 1.088, and the t squared is 1.185. with the average period is 1.073 and the average t-squared is 1.14. This is the fourth data collection with a length of 32 centimeters. Now, the highest is 10.64 seconds, which is lower than before because the length is shorter than the last data collection. Now, 10.64 seconds that took it time to complete the movement, and the period is 1.064 and the t-squared is 1.133. With the average period 1.058 and the average t-squared is 1.121. Now, this is a fifth data collection with a length of 36 centimeters with a slight increase of length from the third one. Now, the highest one that it took this is the highest time that it took for the pendulum to complete its movement, which is 10.95 seconds with a period of 1.095 and a t-squared of 1.201 with an average period of 1.077 and the average t-squared of 1.162. Now, this is the simple pendulum graph that I have created from the experiments that we have did. Now, this you can see that the length as the length gets longer, the time that it took for the pendulum to complete its movement and the period squared to complete its movement gets higher. As you can see at the 20, it sits at 0.86, while at the 36 centimeter, it sits at 1.2 centimeter, 1.2 t-squared. Now, this is how we search for the gravity for each of our experiments. Now, I'm taking a little bit liberty to use the highest one of the experiment, which is first g equals 4 pi squared times 0.2, that is the length, per 0.896 squared, that is equal to 9.83 meters per s squared. And then the second one is g equals 4 pi squared times 0.26 per 1.021 squared, that is equal to 9.84 meters per second squared. And then the third one is g equals 4 pi squared times 0.32 per 1.133 squared, that is equal to 9.84 meters per second squared. And then fourth strength, it is 4 pi squared times 0.35 per 1.185 squared, that is equal to 9.83 meters per second squared. And then the fifth one is g equals 4 pi squared times 0.36 per 1.201 equals 9.85 meter per s squared. Now, what can we get from this experiment? The summary is that the experiment successfully demonstrates that the theoretical model provides valuable insights to pendulum motion. And we can see that the longer the string is, the longer it takes for the pendulum to complete its movement. Thank you for watching, and I hope to see you again.